Welcome to Explore Media Formats for the Web. I'm Jean-Yves Avenard, a WebKit engineer, and today I will go over media formats supported in Safari, focusing on images and video, and introduce you to some new technologies we made available in Safari 17. We are adding support for some new image formats, and I'm going to help you choose the right one for your site after a little presentation on the most commonly found ones. Then I will guide you on optimizing MSE with a brand new technology we've implemented in Safari 17. Finally, I will present how you can add AirPlay support to your video using Media Source extension. Over the years, three formats have been the most widely used. They are supported by all browsers and are easily created and deployed, but technology has made tremendous progress over the last decade, and new great formats are now available. The incumbent formats are GIF, JPEG, and PNG. Let's look at them in more details. GIF, or as we properly say in my country of birth, GIF, a format introduced 36 years ago that is best suited for simple animations, memes, and social media content. It does not support a full color palette, being limited to 8 bits color at a time. Since it's a lossless format, file sizes can be quite large, making it less suitable for larger animations. Then we have JPEG, introduced over 30 years ago. A great feature is progressive loading, where you can see some of the image before it's fully loaded, particularly convenient at a time where network speeds weren't particularly fast. It is best suited for photograph and other images with a lot of color and details. It's a lossy format. That means that some image data is lost during the compression process. The compression also allowed for smaller file sizes and faster loading times. With GIF having so many limitations, PNG was created 26 years ago. PNG supports transparency, which makes them useful for overlaying images on top of each other. It's great for images with large area of solid color, or sharp text such as logos or illustrations like the WebKit JavaScript squirrelfish. It's lossless and doesn't compress as well as JPEG, so it's not very suitable for big images with lots of color. Like GIF it was designed to replace, it supports animations, though I've rarely seen those in a while. By using these formats, you can reach all your users, regardless of what web browser they are using. Safari 17 supports an additional 4 extra modern formats, which you will want to use in addition to the legacy ones, and that I think makes the most sense. While they are great and pretty much all interchangeable, they each have their key advantages over the others. WebP was added to Safari 14 and macOS Big Sur. This is a modern image format that uses advanced compression algorithm to achieve smaller file sizes without sacrificing image quality. WebP files are typically smaller than those earlier image formats, which can help improve website performance and loading times. WebP lets you do animations with video-like quality, and so use it where it's a bad idea to use GIF due to their size or lack of colors. One exciting addition to Safari 17 is JPEG XL, a new image format that's designed to offer high compression rates and image quality. JPEG XL uses a new compression algorithm called modular entropy coding that allows for greater flexibility in adjusting the compression ratio. It is well suited for images that may be served over slow connections, like JPEG, so users can see something before the whole image is fully loaded. A key feature of JPEG XL is that you can losslessly convert, that is, not occur any data loss going from your existing JPEG files to JPEG XL, all while significantly reducing their size by up to 60%. It's a relatively new format and so may not be widely supported by all devices and browsers. AVIF is another modern image format that uses the AV1 video codec to achieve high compression rates without sacrificing image quality. Widely supported across all browsers, it is well suited for live photos and supports up to 12 bits color depth. It also has the broadest support, and you should include it as fallback. AVIF can be up to 10 times smaller than JPEG. In Safari 17, we added support for HEIC, also known as HEIF. It's an image format that uses the HEVC video codec compression algorithm to achieve small file sizes. But since it's not widely supported on other platforms, you will probably only want to use it as an alternative format. This is the format used by iPhones and iPad to save photos, so you can directly handle photo uploaded from your iPhone with no conversion. If you intend to display images using a WK Web View inside your app, this is the format you should be using, as it's hardware accelerated and can be rendered quickly and efficiently. One of the key advantages of JPEG XL, AVIF, and HEIC, however, is that they support both wide color gamut and HDR. Supporting billions of colors, the large color gamut allows more color to be preserved on file and represented on screen. HDR lets you better define how dark the darks can be and how bright the brightness can be and how much light can be taken in. Together, you get more vibrancy to outdoor landscapes or very bright scenes with lots of contrast, or have perfect rendering of those beautiful complex skin tones. As you want your website to continue supporting all widely deployed web browsers, you will likely still need to provide GIF, JPEG, and PNG for the years to come. However, by offering these extra formats, you can make your site quicker to load and using less bandwidth while still being compatible. You really don't need to choose. Let me show you how. Declaring an image element with a JPEG XL image means older browsers and browsers that don't support it will get a broken image. The picture element in HTML allows you to specify alternative sources, allowing the browser to choose a format that it supports. You can even provide multiple alternative sources, prioritizing the format that gives the best performance. The browser will look over the list of available formats from top to bottom. So here, it will use HEIC first if supported. If no matches are found, or if decoding failed along the way, the URL of the image element source is selected. That's how easy it is to provide the right format for people, regardless of device support, without the need for looking at the user agent string or worry about the browser the user will use. You don't need to choose, let the browser do it for you. Now that we know the modern image formats we can use and when to use them, let's take a look at video. And specifically, let's dive into adaptive streaming video. The evolution of video presentation on websites has been a fascinating one, and it has come a long way since the early days of the web. Here are some of the key milestones in the evolution of video presentation on websites. In the early days of the web, video was not commonly used on websites due to technical limitations. Websites were primarily made up of text and static images. In the early 2000s, browser plugins like Flash and QuickTime emerged as a popular way to add video to websites. And in 2010, HTML5 was introduced, which made it possible to embed video directly into web pages without the need for those plugins. This made it easier to add video to websites and also allowed for greater flexibility and control over how video content was displayed and played. And WebKit was at the forefront of this revolution. With the rise of mobile devices, it became increasingly important for websites to be able to display video content on smaller screens. This led to the development of new techniques to allow websites to adapt to different screen sizes and orientations. HTTP live streaming was introduced by Apple in 2009. One of the key features of HLS is its support for adaptive bitrate streaming, which allows for the delivery of the best possible video quality based on the user's internet connection speed and device capabilities. Adaptive streaming in HLS works by dividing the video content into small chunks or segments, typically between 2 and 10 seconds in length. Each segment is encoded at multiple bit rates, and these different bitrate versions are made available to the client via a manifest file, in the form of an M3U8 multivariant playlist. HLS does a brilliant job at selecting the best suitable variant. It's very simple to use and is the best solution for the end users. Unfortunately, on desktop, not all browsers include support for HLS, and even today only Safari supports it. Web developers wanted more control and more flexibility, such as the selection and transfer of metadata or the ability to play DRM content on desktop. And so in 2013, the Media Source extension was published by the W3C body. Safari 8, along with other browsers, quickly added support for it. Media Source Extension, or MSE, is a low-level toolkit that allows for adaptive streaming. By giving the web page more control and responsibilities for managing buffering and resolution. Overall, MSE has been a game changer for web developers. It has enabled the development of high-quality streaming experiences on the web and is now the most used web video technology. MSE has some drawbacks. It isn't particularly good at managing of buffer levels, the timing and amount of network access, and the media variant selection. These inefficiencies have largely been immaterial on relatively powerful devices like modern general-purpose computers. Power usage on mobile devices was much higher than with HLS native player, and so MSE was never made available on iPhones because we couldn't achieve with MSE the required battery savings. All our testing of various sites proved that enabling MSE would have led to a regression in battery life. On devices with narrower capabilities, or where the connectivity is spotty at best, it can also be difficult to achieve the same quality of playback with a Media Source API than is possible with HLS. One of the reasons for this is that MSE transferred most control over the streaming of metadata from the user agent to the application running in the page. This transfer of control added points of inefficiencies. The page does not have the same level of knowledge or even goals as the user agent, like they may seek the cheapest networking connection path, and this typically led to much higher power usage. And this year, we wanted to address those drawbacks, and we worked hard to find a way to combine the flexibility provided by MSE with the efficiency of HLS. And so I'm super pleased to introduce this new technology that combines the best of MSE with the element that makes HLS awesome: the Managed Media Source API. A Managed Media Source is one where more control over the media source and its associated objects has been given over to the browser. It makes it easier for media website authors to support streaming media playback on constrained capability devices, all while allowing user agent to react to changes in available memory and networking capabilities. Let's go over some of the differences over the old MSE. Managed Media Source can reduce power usage by telling the web page when it's a good time to buffer more metadata. When not buffering, it allows the cellular modem to go into a low power state for a longer period of time, increasing battery life. When the system gets into a low memory state, Managed Media Source will intelligently clear out unused or abandoned buffered memory, making pages more efficient. Because Managed Media Source tracks when buffering should start and stop, the page's job of detecting low buffer and full buffer states becomes much easier. The browser does it for you. With this improvement in place, Safari can send media requests over the 5G modem. This allows your site to use a blazingly fast 5G network to load metadata incredibly quickly, while having a minimum impact on power use. And if you need to play a live show, Managed Media Source will automatically detect it and switch to LTE or 4G where available to extend your battery life. You are still in a driver's seat. You are still in control on which resolution to fetch, how you download each segment, and from where. Managed Media Source only provide hints and give you a more efficient version of MSE. By using Managed Media Source, you will save bandwidth and battery life, allowing your user to watch your video for longer, not only on their iPhones, but also their iPads and Mac. Let me show you how easy it is to migrate from MSE to Managed Media Source. Transitioning your video player from MSE to Managed Media Source is easy and only requires a few steps. Here, I will open a very simple HTML page I had used multiple times in the past to test MSE development. It creates a video element and loads 12 seconds of data and then plays it. all the logic actually occurs in a utility file mediasource.js that is included. Let's look at it, and in particular the method runWithMSC. RunWithMSC waits for the page to load, create a video element, and attach it to a media source object, and append it to our HTML's body. First, you need to ensure that Manage Media Source is available. This is easily done by checking the document that Manage Media Source object is defined, and if not, fall back to using MSC. Then replace any call to media source by Manage Media Source itself. Another way, and in my opinion easier, is to override media source itself like so. You define a method getMediaSource and set a media source shim. And now, whenever you are referring to media source, you will actually be using Manage Media Source instead. Manage Media Source should always be your first choice over the older MSC. Now, back to my HTML page. After creating source buffer, now manage source buffer, you add two event handlers. Start streaming will notify the player when it should start fetching new content, and add it to the manage source buffer. And one to handle the end streaming event to tell when the player needs to stop fetching new data. The user agent now has determined that it has enough data and it can now enter low power mode. For this demonstration, the end streaming event handler is just a placeholder. Unlike with MSC, your source buffer may evict content at any time, and not just when appending data. With MSC, it was never a good idea to assume your buffered range only increased when appending new data, which would have caused playback to stall, and the MSC specification encouraged you to regularly check. So you also need to add an event handler for the buffer change event, where you will need to check which data was evicted. If you follow the guidance of the Manage Media Source events and only append data when the element asks you to do so, you will get access to 5G speed on iPhone and iPad, giving your users access to higher resolutions, shorter rebuffering time, and best possible battery life. You are now ready to handle adaptive streaming using the new Manage Media Source available in Safari 17. Though if all you care about are Apple devices, using HLS instead will likely make more sense. There is one more thing your user will want to continue doing: the ability to AirPlay to their favorite TVs. One of the great benefits of using native HLS was the automatic support for AirPlay. With AirPlay, while sitting on your couch, you can move the video from your phone to your big AirPlay device. AirPlay requires a URL that you can send, which doesn't exist in MSC, and this created a problem we also wanted to resolve. In the choosing the right image format earlier, I showed you with the picture element how you could add alternative sources. The video element offers the same mechanism. Simply add your HTTP live streaming playlist to a child source element for the video, and when the user AirPlays your content, Safari will switch away from your Manage Media Source and place the HLS stream on the AirPlay device. Safari will automatically add an AirPlay icon to the video player control and let the user AirPlay the video. If this all sounded too complicated, you can use frameworks such as HLS.js that will support Manage Media Source automatically when available and will do all the hard work for you. Making use of HLS.js for handling your video is fairly easy and usable on all web browsers, even those not natively supporting HLS. First, you will need to create a video element in your HTML file like usual. We first check if HLS is natively supported by the browser. If it is, we can directly set the video source attribute to the manifest URL. If not, we check if HLS.js can run, and if so, create a new instance of the HLS.js library and attach it to the video element with ID myVideo. We then load the HLS playlist file, in this case myvideo.m3u8. That's it. With these steps, you should be able to play HLS videos on most browsers. When designing Manage MSC, we wanted to make sure that nothing was left out by accident, and that users continue to get the same level of features as they did in the past. So to activate Manage MSE on Mac, iPad, and iPhone, your player must provide an AirPlay source alternative. You can still have access to Manage MSE without it, but you must explicitly disable AirPlay by calling Disable Remote Playback on your media element from the Remote Playback API. And that's it. Manage MSE supports all the same great technology we added last year, such as SharePlay, Specialized Audio, or HDR. Manage MSE is available in Safari 17 on macOS and iPadOS and behind an experimental flag on iPhone. We're so excited for this to finally be coming to iPhone. I hope you'll try the new image format and experiment with Manage Media Source. Please make sure to test your site with Safari. Also, we release Safari Technology Preview fortnightly, where you can test the latest new features as they become available and before it reaches end users. Like all actively developed programs, glitches and bugs happen from time to time, and we would be immensely grateful if you reported those to bugs.webkit.org, should you encounter them. You can also submit comments or suggestions. We are always listening. You can learn about new CSS features in Safari, in What's New in CSS, and check out Rediscover Safari developer features to learn about turning on feature flags to try out Manage Media Source. Thank you for watching.